Now we are moving to cardinal points. The major cardinal points we have 4, we have 8 cardinal points, we have 16 cardinal points, we have 32 cardinal points. But for this bearing and distance, we will be laying more emphasis on the 4 and 8 cardinal points. So the 4 cardinal points is also taking us back to quadrants. From here, this is the center, this one is the north pole, and this one is the south pole. This one is the east, while this one is the west pole. So this is the 4 cardinal points, and wherever you are, you have the north, you have south, you have west, and you have east. So this is 4 cardinal points. So the angle between the north and the east is 90 degrees. The angle between the east and the south is 90. Between the south and the west is 90 also, and between the north and the west is also 90 degrees. Now from there we can bring out our 8 cardinal points. This is still our north pole, south, this is west, and this is the east. So bring out something from here, and this one will be northeast, while this one will be southwest. This one too, we have southeast, and this one we have northwest. So if you look at this one, we obtain northeast by breaking north and east by breaking them into 2. So the angle between this north and this northeast is just 45 degrees. The angle between northeast and east is also 45 degrees. This one too, between southeast and east is 45. Between south and southeast is also 45 degrees. And from here, we have bearing. Now we have 2 major types of bearing. The first one we have is what we call surveyor's bearing. And the other one we have is what we call compass bearing. Now when we talk about surveyor's bearing, that is the type of bearing that is starting from the north pole. And starting from the north pole, the movement is clockwise. That is the way a clock operates. Now, example of this compass bearing is if you have something like 060 degree. The meaning of this 060 degree is this bearing is taken from the north pole like this. This is our north pole, so we started from here. Then this is the 060 degree there. Even if you come across something, or if you have something like this 170 degree, if you have 258 degree, all these ones, they are examples of surveyor's bearing. But the other one, compass bearing, example of compass bearing is when we have south 40 degree west, or if you have north 70 degree east, and so on. These ones, they are called compass bearing. So when we have a question on bearing, it can be in the surveyor's form. They can give us the bearing of a particular place in the surveyor's form, or they can give us in the compass form. So from here, this 060 degree is equivalent, this 060 degree that we have there, which is a surveyor's bearing, is equivalent to, that is equivalent to north 60 degree east. This and this, they are the same thing. Also, another one, if you have this one as, maybe, for instance, if you have this bearing as 150 degree, this 150 degree is equivalent to this one. We have to take it from the south pole. There's nothing like east 60 degrees south. It's not possible. But we can have south 60 degree west. So the north or the south comes first before the east or the west. So this 150 degree is equivalent to south 30° east. And it is 30° because if you move from this north pole to this south pole, we are moving on a straight line. An angle on the straight line is 180°. So, but from here to this line is 150. So the one left here is 180 minus 150. So that is where this 30° here is coming from. So those are the major types of bearing that we have. So when we get to interpretation of questions, we need to interpret the question the way we have it. When we have that a man is leaving his base camp and moving on a bearing of 060°, for instance, we assume that this is the north pole. Moving on a bearing of 060° is clockwise. The man moved to his right. If we should interpret that as the man moving to the left, then we are wrong. But if the question is giving us, if the question is coming to us as a compass bearing form, then that surveyor's bearing will not be able to satisfy that. But we must know when we are talking about surveyor's bearing and when they are talking about compass bearing with these examples that are set for that. I have a question. Why do we have surveyor's bearing to always be clockwise? Now, when we have these 4 cardinal points, as I explained earlier, a surveyor's bearing is taken from the north pole and it is taken in the clockwise direction, like this. But for a compass bearing, at times we have it in a clockwise direction and at times we have it in an anti-clockwise direction. For example, if you want to draw the compass bearing for north 75° east, north, this is the north pole and this is east. We are coming from the north pole and we are moving 75° east towards the east direction. So that one we have this, and we notice that this one is clockwise. But if you look at this one, if you have south, if you have north 50° west, for instance, we have this is north and this is west, while this is east and this is south. So this one, the interpretation is we are moving 50° from the north pole to the west pole. So we have this 50° west. And this one is not clockwise, it is anti-clockwise. So for compass bearing, we can have it as clockwise and we can have it as anti-clockwise, depending on what we are to locate. I have an example here which says a town P is 150 kilometers from a town Q. So this word from is very important when it comes to bearing. We are taking it from that particular point or town that follows that from is very important because we are taking that bearing from that point, not from the first point that we are given. So in the direction 050°. And now this 050° is telling us about surveyor's bearing. So it means after drawing our 4 cardinal points, we take our bearing from the north pole clockwise. Now, what is the bearing of Q from P? That's the question. So from town Q, this is Q now. Q, this is north, west, east, then this is south. But this is town Q. From Q, and the bearing is 050. So we start from here, north. So this one is P, and this is 050°. So this still remains north, south, west, east. Now the bearing of this point from this point is 050. And the question is, what is now the bearing of this point from here? And the bearing is to be taken also from the north pole. We take it like this. And what we are interested in there is to trace that angle from this north pole to the line that is connecting the 2 points. And this is the line. So from here, what we have angle NOP. And the middle of NOP, this O is telling us that this is the origin of everything. NOP. This is because this is town P. That's why we have NOP is equal to 50 degree, this angle. And there's something we call alternate angles. Alternate angle is just the Z angle. When we have a figure that is like this Z, so this angle A and this angle A, they are the same. There is a theorem that says alternate angles are equal. So if you look at this one, we notice that this one, and this is just like this Z that we have here. So which means this angle A and this angle A, they are equal. This angle A and this angle A, they are equal from these alternate angles that we have here. So as this place is 50 degree, then this angle A is also 50 degree. Angle SOQ is equal to 50 degree. And the reason is alternate angles. So back to what I said we trace it from the North Pole to the line. We now know this angle as 50 degrees. So what we need now is from A like this to this line. So therefore, bearing of Q from P, that will be the angle from A to this east is 90. The angle from this east to this south is 90. Then from A to A, from what I derived there, is 50 degree. And this one is 230 degree. Now if the bearing of P from Q is 50 degree, then the bearing of Q from P is 90 plus 90 plus 50, which is giving us 230 degree. And this is taken clockwise, and this form is referred to as the bearing in the surveyor's form. But if you are to take it in the compass form, the bearing of Q from P is south 50 degree west. That is in the compass form. But in the surveyor form, the bearing of Q from P is 230 degree, taking it from the North Pole in the clockwise direction. Example says a man who could not trace his route was directed on the following instructions to get to his destination. The direction given to the man is he should walk 6 km east and 8 km north from a starting point. And the question is, we should find his bearing from the former point and the distance covered by the man. So we have this. The man is starting from A. The first instruction is that the man should walk 8 km due east. So let's say this is the starting point of the man. I'll call that one A. Point A. The man is to walk 6 km east. This is north, south, west, east. East. 6 kilometers. Now, the man will not come back to the starting point. But from A, the man will go ahead with his journey. And getting to this place, the man is to move 8 km north. So let me call this one B. This is north, south, west, east, and I have this one as west. So the man is to move 8 km north. So I'm taking this point C as the final destination of the man. And now the question now is asking us that we should find his bearing from the former point. The former point is the same as the starting point. Now that question is asking us that we should find, by taking that bearing from the North Pole, taking it clockwise, we should find this angle A. I will call it alpha. And also, this one, we are giving this one as 8 kilometers. And we should calculate the distance that the man covered to get to his destination. The man started from A, he moved 6 kilometers due east to B, and getting to B, the man moved again and covering another 8 kilometers to get to point C. So this one is a right angle. From there, the first thing we have to do is to get our bearing. So we need to get this alpha, but there's no how we can get this alpha without getting this angle inside the triangle. I will name that one as theta. I said we can use different things to denote angles. So I will use this as theta, and I will apply what we call trigonometric functions that we have done earlier. And to theta, this one is opposite, this one is adjacent, and the side facing that 90 degree is hypotenuse. Now, I know opposite, I know adjacent, but I don't know the hypotenuse, and I want to use trigonometric ratios. So from there, I will combine opposite and hypotenuse. So I have opposite over adjacent to be tan theta. That is from TOA. So tan theta from there, the opposite side is 8 and the adjacent side is 6. Then we have tan theta, 6 in 8 will give us 1. We're having 2 left. 6 cannot go in 2, then we have that decimal point A. So 6 in 20 will give us 3. That is 18. Minus 20, we still have 2 again. In 20, we have 3. That is 18. We still have 2. 6 in 20 it will still give us 3. And this one will still give us 3. And this is now taking us back to quadrants. From here, tan theta is positive. And tan theta is positive only in first and fourth and third quadrant. But there is no instruction that is asking us to find the equivalent of this theta in the third quadrant. So we only need to get the value of theta from the first quadrant. And what we do here is we check for arctan. That is the same thing as inverse of the tan of 1.3333. And what we have there, theta is just 53.1 degree. That is the angle A. But what we need is actually this angle from this north pole to the line that connects the movement of the man from the starting point to his final destination. And we get that this one is a right angle. An angle in a right angle is 90 degrees. So the answer we have obtained for theta, we just remove that answer from 90 degrees. And that will give us the bearing of the man from his former point. So therefore, bearing of the man from his former point is 90 degree minus 53.1 degree, and that is 26.9 degree. Sorry, 36.9. 36. We can put 0 in front to indicate that the movement is clockwise. Or we can ignore the 0, but we need to put that 0 to show us that that bearing is taking, the form of that bearing is surveyor's bearing. That's the essence of the 0 that we have in front of the answer that we have there for the bearing. The last part of the question is asking us for the distance covered by the man from his former point to his final destination. And the triangle that we have here is a right angle triangle. So, and I was able to explain Pythagoras theorem during our last lesson. From here, we are looking for the hypotenuse. For the distance covered, using Pythagoras theorem, it says the hypotenuse. The hypotenuse there is, we have hypotenuse square is equal to the opposite square plus the adjacent square. So I represent our hypotenuse with maybe y. or any alphabet. We can use X, we can use K, we can use Q, or any alphabet of our choice. So the hypotenuse is y square. The opposite side, that is 8 square. Then the adjacent side, that is 6 square. So we have y square. 8 square is same thing as 8 multiplied by 8. Then 6 square is same thing as 6 multiplied by 6. So we have y square to be 64 plus 36. So y square is 100. So the next thing to do from here is to find our square root. And to what I explained about square root the other time, I said we can use factor method. We have 100. In case you are not with calculator, we look at 2. 2a will give us 50. Because the last number is 0, so 2 will still be able to divide it. So 2a will give us 25. 2 cannot divide 25 without leaving a remainder. And 3 cannot divide 25 without leaving a remainder too. We are using prime numbers to divide. So we move to 5. 5 in 25 will give us 5. Then 5 in 5 will give us 1. So we take them in 2s. So this one is 2. So y is equal to square root of 100. This one we take them as 1, 2. And these 2 also we take them as 1. 2 multiplied by 5. Therefore, from there, y is equal to 10 kilometers. So therefore, the man that started from A has covered a distance of 10 kilometers to get to C, and the bearing of his movement from A is also 0.36 degree point, 0.36.9 degree, and that gives the solution to that question.